This video contains the solutions to the Take-Home Problems number 2 handout. Make sure to try to work through the problems on your own before watching this video to see the solutions. For this first one, we're asked to simplify this algebraic expression. The first thing we're going to want to do is distribute the multiplication through our parentheses. So this 3 is going to be multiplied by 2x and also by 1. And this negative 4 is going to get multiplied by 5x and also by 6. So 3 times 2x minus 3 times 1, and then minus 4 times 5x minus 4 times 6. Now we can do some of these products in our heads. We don't have to write it out in this level of detail, but I'm just writing it like this as a first step to show you where it's all coming from. So now we work out the products. 3 times 2x is 6x, 3 times 1 is 3, 4 times 5x is 20x, and then minus 4 is plus 4, and 4 times 6 is 24. And now we collect like terms. So the 6x minus 20x, that's going to give us negative 14x. 6 minus 20 is negative 14. And then minus 3 plus 24, that's going to give us plus 21. And so our final answer is negative 14x plus 21. For this one, we're evaluating an algebraic expression. So when we do that, we want to replace all of the x's with 1/2 and all of the y's with 2/3. And whenever we substitute into an algebraic expression, we want to take the numbers that we're substituting in and put them in parentheses. So the x gets replaced by 1/2, the y gets replaced by 2/3, and then on the bottom, y gets replaced by 2/3, and then we have that expression. Now that's a fairly complicated expression with fractions within fractions. So what we're going to do is we're going to simplify the top and simplify the bottom, and then see what we have. So on the top, 3 times 1/2, that's 3/2. If it helps, think of 3 as 3 over 1, and then we multiply fractions by multiplying the tops and multiplying the bottoms. We don't need the parentheses here around the 2/3. On the bottom, we just have 2/3 plus 1. Now we can rewrite 1 as 3 over 3. That common denominator is going to allow us to add the fractions together on the bottom. So we have 5/3 on the bottom. On the top, we have different denominators. We have 2 and 3. So the common denominator there is going to be 6. To convert 3/2 to 6ths, we multiply top and bottom by 3. So that gives us 9/6. And then to convert 2/3 to 6ths, we multiply top and bottom by 2. That gives us 4/6. So here I multiplied top and bottom by 3, and here I multiplied top and bottom by 2 to get 6 on the bottom of both of those fractions. Now that we have a common denominator on the top, 9/6 minus 4/6 is 5/6. So we have 5/6 divided by 5/3. Now we have a fraction within a fraction, and so what we're going to do there is multiply top and bottom by something that's going to get rid of the denominators of both fractions. So we want to multiply top and bottom by a number that's going to cancel out the bottoms of those fractions. And in this case, a common denominator between 6 and 3 is 6. So multiplying the top by 6, the 6's cancel out, and I just get 5. And on the bottom, when I divide out the 3 and the 6, I'm left with 2. 5 times 2 is 10, and so I have 5/10, so no longer have fractions within fractions. But one last step now, I've got to write this in lowest terms, which I can do by dividing top and bottom by 5. And that gives me my final answer, which is 1/2. All right, now we're solving a simple equation. We've got 6x minus 25 equals x. What you want to notice here first is that we have x in multiple places in this equation. And so our first priority is to get the x's together. We only want there to be a single x in our equation. Because remember, our goal at the end is something that looks like x equals a number. And so if we have multiple x's, that's going to make it harder for us to get to that eventual goal. So what we're going to do is we're going to add or subtract things from both sides using opposite operations to get the x's together. In this case, I'm going to subtract x from both sides. So on the right-hand side, I have 0. I still have the minus 25. And now 6x minus x is going to give me 5x. So I've accomplished my first goal of getting a single x in my equation. And now I want to get everything else other than that x away from the x. I want to move all the other stuff to the other side of the equation. So again, using opposite operations, I'm going to add 25 to both sides. That's going to cancel out the subtracting of 25. So then I'm just left with 5x on the left and 25 on the right. X is being multiplied by 5, so the opposite operation is to divide by 5. And 25 divided by 5 is 5. So there's my final answer. This time we're simplifying an algebraic expression involving fractions. As always, whenever we want to add two fractions, we want to find a common denominator. And the common denominator, we can always find a common denominator simply by multiplying our two denominators together. So our common denominator here is going to be 2x. To get the first fraction to have a 2x on the bottom, we have to multiply top and bottom by x. So on the bottom we'll get 2x, and on the top we get x times x, which is just x squared. For the second fraction, to get a 2x on the bottom, we have to multiply top and bottom by 2. That gives us a 2x on the bottom, and on the top 2 times 2 is 4. Now we can add the two fractions together, and on the top we have x squared plus 4. So that's our simplified sum. For this last problem, we will need to simplify a difference of two polynomials. So the first thing that we need to do is distribute the negative through the second polynomial. This is similar to the first problem that we talked about where we had to distribute the parentheses as our first step. So we're going to take this minus sign and distribute it across everything in this second set of parentheses. We don't really need the parentheses around the first polynomial, so I'll drop them. 4x cubed minus x plus 10 minus 2x squared minus 5x, and then minus 8 is plus 8. Now we're going to collect like terms. And in this case, for the like terms, we have to pay attention to the powers of x. So x cubed is not a like term with x squared. So if we start with our 4x cubed at the start, there are no like terms with 4x cubed. There are no other terms in this sum that have x cubed as their variable part. Similarly, there are no like terms to 2x squared, where we always go from the highest power down to the lowest. So I'm going to look at the x squared next, and there's no like terms with that either. So next we write negative 2x squared. The next lower power of x is x to the first power, which is just x, and we see two like terms there. There's a minus x and a minus 5x. Minus x minus 5x gives me minus 6x. And then finally, the constant terms, which are the terms with no x's at all, are the 10 and the 8. And 10 plus 8 is 18. So there's my simplified polynomial.